So how are we going to solve using inequalities using the graphing calculator? Looks, in terms of what you put in the calculator, it looks just like we did in equations. So when we do calc intersect, we're going to put in a y1 and a y2, the left and the right side. Before, when we did it, it was the left and the right side of an equation. Now it's the left and the right side of the inequality. But you would just have to add a few things. Most of it is in the interpretation. Otherwise, it looks exactly the same. So I need to put what I'm putting in the calculator, the input. I need to add just one more statement for the input that I require. And then we need to draw it with the scale. We need to put in the points of interest. And then we need to write the solution set. So I know that my document camera isn't the best, but at least you can see what buttons I push and hopefully we'll get close. So we are going to start by entering, in this case we have, we're going to use calc intersect. So we're going to put what we're putting on the left and the right hand side of this. And it's going to be, oh, I need to have a pen to draw with here. Hang on. Y1 is equal to the left-hand side, which is the absolute value of 3x minus 1. No, minus 2, excuse me. Y2 is equal to the right-hand side. That's the 4. But now we need to add. The left-hand side was y1. And we want that to be greater than or equal to y2. So this right here is the new, when it's an inequality, you're signaling that if you're doing this on a test problem, or if you're doing this for a homework problem using your graphing calculator, that's your signal that, okay, I know I'm just entering this in the calculator normally, but this is going to have to be my interpretation. So we're going to go ahead and then put that into the graphing calculator. So the first step, oh, you have to see what I'm doing. Hang on. Whoops. There. Like that. We turn on the calculator. That's down here. What does it say? Do not show again. Choice number 1. I'm just going to clean up by hitting clear. And then we go into y is equal to, I know that's really hard to see on the screen because of the lighting, but I don't know how to change that. But it's the one on the left-hand side. Look on your own calculator. It says y is equal to. And then we're going to put in the left-hand side, which was the absolute value of 3x minus 2. Where do I find this? In math. The menu is going to be numeric. So I'm using the arrow keys to get to the second menu up there at the top, at the very top up here, right? We want to go to numeric. Choice number 1. Now, I have a newer calculator, so it's a newer TI-84, so it will put in the absolute value bars. If your calculator won't do that, it'll just say ABS. That's fine. You just have to remember to put a parenthesis at the end of the absolute value. So we're going to put in 3. The quick button for X is right here. Instead of using the alpha button, you can look through the lettering is all over each of the buttons in green. So it's the fast way, because you use X so often on this calculator, they made a quick button for X, is right here. X minus 2. If you have an older calculator, you need to end the parenthesis. Mine is fancy enough now that it put the absolute bars in for me. So then I'm going to use the arrow down key or enter. And then you see the equal sign here is dark. That means it's active. Now go down to the second y equation, which is going to be y2 is equal to 4. If I hit enter, now both of them are active. When I graph this, I have a couple options. I could just hit graph. But if I've changed the window in a problem before this a lot, it may not be in the window that I want to look. So I usually say start at zoom 6, which makes the window go from -10 to 10, -10 to 10. If it doesn't fit there, then you can start zooming out a bit and changing the window. So we're going to go to zoom in the middle. Choice number 6. It resets the window from -10 to 10. Now all of the information that I need is there. I know that it's an absolute value, which is a V, and with a horizontal line, and they have two intersections. I need to find those two intersections, just like we did when we were finding equations. I could go in and change the window if I wanted to. I don't need it here, but I would hit window, and then you can control the Y max, the X min and max, the scale that you go by. Does it put a little hatch mark at every 1 or every 5 or every 10, depending on how big my scale is? Same with the Y values here. And then hit graph afterwards. We don't need to, so I'm just going to hit graph, so we're here. Now my job is to find these intersections. So it says above the trace button, it says calc. So that's what we need, and it says it in blue, so that means hit the blue button and then calc. And we want to calculate the intersection. You can either arrow down using your navigation tools here and then go down to 5 and hit enter, or you could just hit the number 5. And then it's asking you, okay, which curve? So I want to use the first and the second curve. The way to navigate, you see they name the curve up here in the left-hand corner. So I want Y1, enter, Y2, enter, and I don't want to guess. We can always just skip that one, enter. And it finds that one intersection for us. Now I see here, oh wait a minute, this is a decimal. I know it looks like -6 repeating, which you should know 6 repeating is 2/3, but let's say you weren't sure. What it does right now, currently this has stored 6 repeating in the calculator, as close to 6 repeating in the calculator as it can. So what I'm going to do is I'm going to go to the home screen. The way to do that is go into, like, if you quit, it says quit here, second, and then quit. And then I'm just going to show you, if I called up 6, the last number we found for X is stored in X. So I can go into math. So I can take that X, go to math, and choice number 1 says FRAC, sorry. Choice number 1, and it converts that into a fraction. So I know that the exact valued answer is -2/3. So, okay, a couple of things. I need to sketch a graph. So going back to this one here, sketch a graph. If it'll let me. Sorry, I'm looking down on my iPad, so come on. I am going to pick not the best straight line here, but it's going from -10 to 10, -10 to 10. My picture looks like this, and another line across this way. I want to find this intersection here, and it was -2/3. If you can give exact values, you're going to do it. And I showed you just on the graphing calculator how to find that exact value. It may be worthwhile for you to actually write down the steps that I did. I know you can refer back to the video, but having to look through the entire video to find how to find the exact value, it may be worthwhile for you actually to do that. So here, I'm just going to go back to our calculator and look. Calculate 5. This is what we have so far. Whoops, I keep hitting that button by mistake. There we go. So this is what we got. We figured out the exact value was -2/3. I could do that with any X. Now I'm going to find the other one. And remember, when you have to find the other one, I have to go through the same process. Second, calc. Choice number 5, but I need to be closest to the intersection I want to find. So I'm using the cursor or the spider or whatever you want to call it. I'm going closer to the second one. So you see I'm moving it back and forth here. Closer, as long as I'm closer to the one on the right, it will find the one on the right. Enter, enter, enter. Oh, there is 2/4, 2/4. That's the order pair. Like that. So now we're basically doing the same thing as we did before, except now we have to interpret. So it is saying, so I'm going to show you this. This is the absolute value is my y1, and the horizontal is y2. So the horizontal is y2, y2, this is y1, and y1. I am looking for where y1 is greater than y2. So in other words, where y1, the absolute value function, is above. The y values is vertical values, right? So if I want y1 to be greater than y2, I want where the y1s are above the y2s. So there are two places where that relationship changes. If I am to the left here of that intersection right there, the y1s end up, and I highlighted, there's a little bit of a delay, so we'll have to wait a second. There's a y1 on the y1 is greater than y2, or is above y2 on the left of the first intersection. So right there where that's highlighted. If I look at the part in between the two intersections here, I'm highlighting the middle part. Not the best there, but let's pretend like I can do that. The middle part there in blue is where y1 is below y2, and then the last area, again, where the next intersection is, the relationship between y1 and y2 change again, and that's y1 is again above y2. So your job, now you don't have to highlight when you do this, but I'm just using it to illustrate. My requirement is that on the x-axis, you need to draw the solution set. So I know that I wanted it to be greater than or equal to, so that's down here on the x-axis is equal to, and greater than or equal to. The equal to means that we fill in the points from 2/3, because I'm only interested in the x's really, and 2 here. But I need to shade on the x-axis for all the x values where y1 is above y2. So that means, that means to the left, in the yellow part, that's going to be true. y1 is above y2. In the blue part, it's not true. y1 is below y2. But in the green portion, it is true again. So therefore, the solution set is going to be negative infinity to negative 2/3, inclusive union 2 to infinity, or if I did set builder, x such that x is less than or equal to negative 2/3, or x is greater than or equal to 2. Oh, you can't see that. I cut that off there. So the whole key is in the interpretation of the inequalities. So it's really important what I highlighted over here, that's highlighted in your mind. Oh yeah, I need to look for where y1 is greater than y2. Now you do not need to have it shaded. So like all of these parts here, it was really just to help me explain. Oh, I lost the y-axis here. It was really only to help me explain. And the same where it says y1 and y2, you don't have to do that. It just helps.